lecture about database hacking, the second half of it here. So, attacking data stores. Filters are a big issue, and you find it all over the place. So if you want to avoid people doing SQL injection, you can just block things like apostrophes, and that'll stop the simplest kind of SQL injection. But you can inject into a numerical field without using quotation marks, and you can also use ways to indirectly create the filtered characters without directly typing them in. So the chur or char function will let you just put in a character from an ASCII numerical value, so you can then append that to other characters. You can build a word with a series of these things, and therefore a filter that just looks for that word won't find it, but the database server will find the forbidden word there. So you have select star from users where name equals uname, and we inject this for the name. That creates select star from users where name equals blank or 1 equals 1, dash dash. But if the dash dash is blocked, then you don't get the comment signal, so you're going to get a syntax error instead of this running because it has an odd number of apostrophes. So if you want to do this without a comment, you just make one that doesn't need the comment. You do apostrophe or apostrophe A equals apostrophe A, so you're going to match an apostrophe on the left and another apostrophe on the right. So now you've got a situation. Wait, should we be seeing the slides? Yes, you should. And I'm seeing them here. Let me know if you're not. I see them here. So they do seem to be being sent out in switch. All right, so then this is another way to get the effect of SQL injection and get a condition that is always true, because name is never blank probably, but A is always equal to A. And this way you don't need the comment signal. So this is one way to bypass a filter that blocks the comment symbols. And if they block select, then you can try this, uppercase and lowercase, put a null byte in front of it. This is a good trick because if the filtering system is written in C or it's running in a web firewall, a client, let me see here. It's refreshed and they went up. Yeah, you got to refresh. Good, okay. Yeah, I'm having to refresh mine more often than usual. Anyway, so if you put a null character in front of it, then C will terminate a string at the null character, so it'll never see the data behind there. But the database software generally will. You can also have select with another select in the middle of it. So after it deletes the select in the middle, there's a select left over. You can have these strings of hexadecimal codes for characters that spell out select, or these strings of hexadecimal characters which need to be doubly decoded to turn into select. The %25 turns into a percent, and then it's %53, which is S, and so on. And all these things may well turn into select after interpretation at the other end and bypass the filter by not being exactly select when they pass through the filtering stage. You can use comments instead of spaces, and that would make this look different. MySQL allows comments within keywords. You can put a comment inside a select word so it won't appear to be select, this sort of thing. This is why, in general, deny listing, where you try to list bad things and remove them, is pretty ineffective because there's no end of sneaky ways to rewrite something so it still has the same meaning, but it doesn't match your template for the things you're trying to block out. And then there's second-order SQL injection, where you put in data which is correctly understood and entered into the database, but later when you use it, is it everyone having glitch? Yeah, just try refreshing your browser, but it does seem to be necessary more often than usual. I don't know what I can do about that. Perhaps it's, I got the only available internet connection here. Yep, probably it seems to be a connection at my end, I guess, although my panel here shows it green. It doesn't show any problem with the internet connection, but I do need to refresh it more often than usual. Yeah, maybe it's the hotel Wi-Fi. Although my OBS is not complaining, so I'm not sure. Anyway, I don't think there's anything I can do but carry on. But let me know how your experience goes. If it's too bad, I can put this lecture off till next time, but let's see if it's usable. Anyway, here's second-order SQL injection. You register an account with this name, including an apostrophe. Now, the correct way to enter a name with an apostrophe is to put in a second apostrophe. This is the double apostrophe is treated as an apostrophe character inside the apostrophe quotes, except this will go into the database and have an apostrophe in it. But then later on, when you try to reset the password, it may be a syntax error when it tries to use it. This apostrophe might cause an error later. And so you could put in a user with a name like this, with the whole SQL injection thing. Select password from user or username equals admin. Then perform a password change, and MS SQL will return this error, syntax error converting the value FME69, because when it tries to print out the error, it performs this evaluation in parentheses. So you can register a user with a name that includes a SQL injection, and then when you activate an error message that would include that name, it will now include that data. So this is kind of a cute trick, and this is what happened here in this famous cartoon from XKCD, where a mother named her daughter Robert apostrophe parentheses semicolon drop table students semicolon began a comment, and now when they use this name later on to assign a grade or make a list of students, it will execute this command, drop table students, and erase the database. So that's second order SQL injection. Then there's other ways to do it. Now, remember we talked about blind SQL injection before. It's easiest when you have some kind of page that returns data from the database, and then you can trick it into returning other data from the database like passwords. That's one way, but what if the results are not on the page? Like a login page. You give it a name and password, then you go to some kind of page, but that page does not include data from the database. It checks your input to make sure it matches some conditions, but it doesn't actually print out anything that came directly from the database, so you try things, other things. You can try shutting down the server with shutdown. You can try dropping tables like we did there. These are things that would happen if it executes the code even though it doesn't display the results. You could retrieve data as numbers. If you have only a numerical field and not a string field, then you can't put alphabetical characters in there with union and other select, but you can you can use the ASCII or substring function to use the ASCII and substring to pick out a single character, and then ASCII to turn it into a number, so you can get numbers. And so here's something to return the first letter in admin, and this is ASCII if that returns 65. So this is how you would do it. You could convert an alphabetical field like a password into a numerical field, so you can put it in a numerical display field. And you can use an out-of-band channel. If you can't get any data from the database directly, you can sometimes make a network connection inside the query language. So here, you can connect to a server here with a username and a password, and then go in. So this is one way to do it. You can make another connection to another server to send data off. And HTTP and Oracle will make an HTTP request, so you can make a web request to an attacker and send in this data to there, so it'll appear in the server log of the web server. The attacker can use a Netcat listener to receive it, or you can put it in the server logs. This will send it off over port 80. You can use a DNS request too. Get host name is the function that will do a DNS resolution, and so you do a DNS resolution of select the password .mdattacker.net. So it'll put the password in the URL and then try to resolve that in a fully qualified domain name, and then resolve that domain name, which will go to your DNS server. And if you monitor the traffic or the logs at the DNS server, you'll see it come in with the password .mdattacker.net, the domain you control. So one of the many cute ways to do it. Then MySQL, you can select into out file. So you can take the data and put it into an out file somewhere on the server. So if you find some ability to write somewhere on the server where you can see those files, this is another way to get output to somewhere visible. And this will actually connect to a remote server on a file share, so that's even nicer. All right. Just checking to see if there's new comments. All right. And sometimes you can execute shell commands. You can use PHP commands sometimes. There used to be something called XP command shell in older versions of Microsoft SQL you can use to actually get a command shell on it. And you can use commands like TFTP mail or telnet to send data off to a remote server, or you can copy data into a file somewhere in the web path if you find a place where you can write data, and then you can just view it by adjusting the URL. So there's lots of ways to hack a server even if you cannot directly see the output of your SQL commands. So let's try a Kahoot. Guess we got everybody who's coming. All right, so which one of these will bypass a keyword filter? This one, these have keywords you'll block like select or drop. This has encoded the keyword as a bunch of numbers, so it'll generally not be filtered by a keyword filter. All right, which construction lets you put letters in a numerical column? Yeah, this one turns numbers into letters, which is not what you want. This is the one that takes a letter and turns it into a number. That's what you need if you're adding it to a numerical column. All right, which defense do you overcome by putting in cell select ect? If you do one round of removing the word select, you'll have another word select. What you need to do is have a iterative loop that keeps removing select until they're all gone, if you want to do that. But that's keyword blocking. That is overcome with that sort of injection. All right, here's the one. What kind of SQL injection was the exploit of a mom here? Second order injection. You put data in the database and it executes some command when you try to use that data. All right, so Blind SQL injection, like we talked about, if the query doesn't return any data from the database and you can't find an out-of-band channel to exfiltrate the data somewhere, then you can still get data if there's any kind of behavior you can detect that depends on your query. So you can say, put in this text, admin apostrophe dash dash for the username, and then you'll be able to log in as administrator. Even though you don't get any data returned, it will let you in as the administrator. So that's one kind of injection that might work. You can try this. This will log in as administrator, and this one will not log in. So now you have a condition here you can adjust. You can now ask a true or false question. So this one will log in as administrator because the first letter of admin is a capital A, and that ASCII of that is 65. This one will not log in because it's not 66. So as we've done before in the projects, you can pump out one letter of a password at a time and ask one true or false question about it, and after a while zero in on things like playing the game 20 questions. You can have conditional errors. Here's one where select username from all users or username equals this, select 10 from dual where this condition is held, and if the condition is true, it will try to select this and crash with the divide by 0. If the condition is false, it will not create the error message. So this is another way to do it, and now you can have a question like, does this username exist in the database? And you'll find out whether that's true or false by whether you see an error. Here's another way to see if this user exists. Like I say, if this user does exist, then you'll get an error message saying divide by 0. You can use time delays, which we've done before. In Microsoft SQL, you can use a wait for delay for 5 seconds, so you'll detect a time pause. In MySQL, you use, here's wait for delay. You can ask your yes or no question. Is the first letter A, or is the first, actually at, or is it A? And one of these will be true and give a 5-second delay, and the other won't be true, and you'll get no 5-second delay. You can test single bits if you want to of a numerical field. You can use power. You use ampersand, so you take 2 to the 0 and ampersand that with a number. Now you're getting the last bit, and then if that bit is greater than 0, have a delay. You can then change this number at the end to get the 2 to the 1, 2 to the 2. You can use 8 queries to get the 1s and 0s of an 8-bit character, 8-bit value. So that's the way to get numerical values out with this kind of blind SQL injection. And you can get delays in MySQL. You can do it with the sleep function. That's one way to do it. For older versions, you can use a benchmark function to create a time delay. And what we've done sometimes use a ping function. That may be common. There's another thing you can do is in Oracle, you can use HTTP to connect to a server that doesn't exist, and then it will cause a delay until it times out, maybe 30 seconds or a minute. Again, a measurable delay if it tries to do that. And so here's one that will cause a timeout if the default account exists. So this condition selects username for all users where username equals DBS NMP. And if that's true, it will then do an HTTP request to the madeupserver.com that doesn't exist. So those are techniques for blind SQL injection. And so you can do more. You can get the data in the database, but if it's shared by other applications, you might be able to access the data in other applications or even compromise the operating system underneath the database server and then pivot and attack other servers inside the network. So you make network connections from it, back out to your own computer to exfiltrate data. You can create user-defined functions to run inside the database. Reintroduced functionality has been removed or disabled if you get database administrator privileges. And this is the one I mentioned before. XP Command Shell is the stored procedure in Microsoft databases that lets you run command line commands. So you could run XP Command Shell of ipconfig going to foo.txt. This is command line control of a Windows system. It's disabled by default in modern versions of SQL, but if you can get the administrator rights, you can turn it back on. There's others. Here's ones that write to the registry and read from the registry, and you can control a Windows machine entirely by controlling its registry. Like I say, it's disabled by default, but if you're a database administrator, you can just turn off the disablement and enable it. MySQL has load files, so you can read a local file, and you can use into-out file to write to a file. So here's one that will make all hosts trusted. This writes into the hosts file, which is what limits which hosts are allowed to remotely connect to your machine. And putting a plus into that will make it accept all IP addresses coming in. This is a common unsafe technique in Linux machines for years. Just let everybody log into your system. All right, and then there's other tools that do this automatically. SQL Map is the most popular tool used by most pen testers. So you can do all sorts of things. It will try all the parameters to find the injection points. It will find the vulnerable fields. It will try all kinds of injections, closing brackets, comment characters, and so on. It'll try to do a union attack, inject custom queries. It will try Boolean conditions, and 1 equals 1 and 1 equals 2. It will try doing conditional expressions and time delays for blind SQL injection. It's a very powerful tool and gets all kinds of data from, it dumps out whole databases easily if there are any SQL injection in there. And you may have done this in the projects if you choose the extra credit part where you use SQL Map. And if you're taking the hacking classes, the pen testing classes, you should have projects where you're practicing with SQL Map. So let's try, let me check for comments in the Twitch. Nothing new. Okay. And let's try another Kahoot. All right, switch method will allow you to execute operating system commands. XP command shell lets you do it on Windows. Which one automates SQL injection attacks? Yep, SQL Map, very powerful tool. All right, which method leaks information even if you have a blind SQL injection? Yeah, I don't really like this question much, but conditional time delays is probably the best answer. You could argue about out-of-band channel or into-out file, but those imply that you're actually getting the data. If you're not getting any data at all, the only thing you can do is a time delay. But sorry about that. I don't really like that question very much. All right. Error message is not a bad answer either. Now, let me make a note. I got to work on that question. Third question. Fair enough. Let's go ahead. All right. So which one of these will read a local file? The load file, kind of obvious. All right. All right, well, we can carry on here. So, if you want to prevent SQL injection, one simple procedure is to block apostrophes. This is a weak defense, but it will stop the most common kind of SQL injection. If you allow apostrophes by doubling them, then you might introduce second-order SQL injection vulnerabilities. You can use stored procedures is far better. You create a procedure as SQL statement go. This makes it easier to reuse code. Now, the stored procedure doesn't necessarily prevent SQL injection. It's just a way to store a procedure. What really does it is, if you define a procedure in principle, you can still do it. You still do the injection. Parameterized queries are what you really need. And the point of these is you specify the query structure with placeholders for each input, and then the data is put in the placeholders. And this way, a data object cannot be misunderstood as a code object. This is the right way to do it, and it looks like this. Select name, ename cell from employee, where ename equals, quote, this is the vulnerable code, where you have a select ending in an apostrophe, then you add the data from the user, then you put in another apostrophe. This is the vulnerable way that we've been exploiting. The parameterized version, instead, you put a question mark there where the name is, and then you use a different way to connect to the database, and you add the data here. The parameter number 1 will be name. This way, the parameter value is inserted here without having apostrophes that match. And there is no way that has ever been found, nobody's ever been able to do SQL injection if you use parameterized queries, because your data is treated as data. It is not in any line of code that is parsed for commands. So this is the perfect solution. Let me just check for comments in the Twitch. Load file, writing it out. Yeah, load file reads, unto out file writes. Okay, all right. So you've got to use the parameterized queries all the time. That would be the wisest thing to do. You might think it's safe if you use it if data didn't come from the user, but the user might have some indirect way to control it. And this is what source code scanners will typically enforce. And another wise thing is to allow values only from an allow list of known safe values. That's another defense measure. All right. And sometimes you can't use parameter placeholders for other parts of the query, like sort by, ascending or descending. So you cannot use parameters for every bit of input. So if you can't parameterize it, then you should use an allow list, so only known good values can go in there. For defense in depth, you should run your database with low privileges, not as administrator, remove unnecessary functions of the database, put on patches, and so on. Subscribe to vulnerability notification services so you find out new flaws and you can work around them. Those are defense in depth measures to help protect you even if these other defenses fail and the attackers find some way to abuse your system. And then there's NoSQL. This had maybe 10 years ago, Facebook switched to NoSQL. It pretty much seems to have fallen into disfavor except for Mongo. A lot of people still like Mongo. Anyway, NoSQL doesn't have structured data necessarily. Keys and values can be arbitrarily defined. So you can have key value lookup, XPath, or programming languages to look up data in NoSQL data stores. And here's MongoDB to inject into it. You can make a new Mongo database, and then you can have a function that will return username and password equal password from it. This is, we'll set some variable called logged in. This is a login code from a Mongo database that will check to see if the username in the database matches the username from the user and the password matches the password from the user. And as you can see, it's got the same kind of structure as SQL injection, it's got apostrophes which have to match, and then you have data that came from the user inside there. So if the user injects data with an apostrophe, then it becomes this, username equals Marcus, and this starts a comment, I think. So you end up with something that will let you in. Here's another injection. You log in with this username, A concatenate with 1 equals, or I guess this is or, 1 equals 1, or A equals A, and that's a JavaScript will interpret it this way, so it will always be true. So there's more examples of injection in a different context. Here you inject into XPath. XPath has XML data stores, so it has these open and closing tags, address and slash address, and credit card and slash credit card, and so on. So you can, if in order to inject, you'd have to put in something like a name that contains these less than and greater than signs. So you could, now an XPath query to retrieve the database would look like this. It's address, email, text. This will retrieve all email addresses. To return all details of the user DAW would be this, address versus surname, text equals DAWs. It's very much like SQL. Those are what XPath queries look like. And so for injection, you would do this query, and it would have an injected thing here in square brackets, which looks up a password from somebody, and that'll get a stored credit card number from a username and password. So this is, yeah, so I guess, yeah, you were, yeah, I'm not quite exactly clear how this works, and I don't have a running one of these to see it. But anyway, you can see the general idea. You do injection rather like SQL injection. Here's another injection, same one we've used a lot of times, and this will just change the clause that was supposed to restrict it to one user into a clause that lets all users come out. So it's still subject to the same kind of flaw. So you fix these by removing these forbidden strings like apostrophe and dash dash. And here's some strings that would also change behavior without breaking syntax. And so if you want to, best thing to do, of course, is filter inputs with an allow list that only allows good characters, and remove, here you can remove characters that are forbidden, but your real defense is to only let known good characters in. LDAP is another one used by Microsoft Active Directory and other systems that lets you store names, phone numbers, and email addresses and retrieve them over the network. And so queries look like this. You match a username. To match any of these conditions, you have the operator first, or, and then a series of conditions, so any of them would be true. To match all of them, you put an ampersand at the front. And this structure actually makes it almost invulnerable to SQL injection, because the logical operator always comes first, so you can't form or 1 equals 1, which is the active ingredient of most of these injections. Applications don't return informative error messages either, so it's actually just the structure of LDAP by accident makes it very difficult to perform these injections and get anything done. All right, let's take a look at the last Kahoot. That looks like I got to refresh mine, like you folks have to refresh yours to keep it visible. Anyway, the Kahoots are here. All right. All right, so which of these is least susceptible to injection? LDAP. I said just the structure of LDAP queries make it very difficult to accomplish anything with an injection attack. What's the best defense against SQL injection? Yep, parameterized queries. So the data objects come in as a parameter which cannot be misunderstood as a code object. All right, what system uses queries like that? That's XPath. Good. All right, what system uses conditions like that? That is LDAP. The logical condition comes first before any parameters, so you can't inject a logical condition and have it take effect. That's why it's more secure. All right, what defense may open second-order SQL injection vulnerabilities? Use doubling apostrophes so people can actually enter data containing apostrophes, which is then stored, but you may have trouble when you use it. All right. Stop this recording.